For lack of a better word, piecewise defined functions are functions that are defined in pieces. And what this means is that over your domain, this is where all your x values are, we're going to specify different parts in different intervals of your x values that are going to define parts of the piece of the function. An example of this, we have our notation for our function f of x, and this could be equal to two different pieces. For pieces that are less than 0, we can say that all values are going to be put into this function and we're going to subtract 1 from them. So for all intents and purposes, this is a line with a y-intercept at -1 and a slope at 1. But this line only exists when x is less than 0. We can define a different piece and we can say x squared when x is greater than or equal to 0. And so we've split our domain into two different pieces. So the way that this works is that we can evaluate certain parts of the piece. We can say or ask ourselves, what is the function of -2? I'm going to find -2 to be less than 0, so I'm only going to look at this part of the function. And then -2 is going to go in for x. So this is going to be -2 minus 1, which is going to be -3. I could also look at a different part of the piece, f of 2. And since 2 is greater than 0, it's going to go into this part of the function here. And I'm going to get 2 squared. So I'm going to do 2 squared. That's equal to 4. 0 is specifically designed to go into this part of the piece where we say x is greater than or equal to 0. So we're going to square 0, and that's of course going to be 0. If we wanted to graph this piecewise function in its entirety, we could establish a coordinate axis of x and f of x, and then we look at the different pieces. Here we have, as I said before, a line with a slope in y-intercept of -1 and a slope of 1. So we have -1 here, and then we also have a positive slope of 1. So that's going to be something like this. What we do want to add is make sure that we have an open circle at the end, because it doesn't quite actually get to that point. Here, when x is greater than or equal to 0, this is x squared. So we know that 1 squared is 1, 2 squared is 4, as we found out here, and this is going to give us a quadratic. We're going to have a solid dot here, since we know that f of 0 is equal to 0, and then we can plot our parabola going through those points.